Hello everyone, in this lecture we are going to see the measurement of inductance by the help of Maxwell inductance bridge. Okay, in last lecture we have seen the bridge circuitry, the basics of AC bridges, that how in balance condition, what is the balance condition and what will be the equation of the impedances we used in the all four branches. So first is for measurement of inductance, first category of bridge is Maxwell inductance bridge. So here in that you can see that four branches are there, and the points are given as A, B, C, D, and the AC supply has been given. The voltage drop across first branch is E1, E2, E3 and E4, and that is the detector, and the current in this branch is I1 and this branch is I2. Okay, so in this is the variable resistance R2 and the variable known inductance L2. The resistance and inductance which we need to measure is L1 and R1. So these are the L1 is our unknown inductance and R1 is our unknown resistance, and R3 and R4 are the fixed non-inductive resistance. The value of those resistance are known to us. So we can see here that L1 is our unknown inductance, R1 is our unknown resistance, L2 is our variable inductance, R2 is our fixed resistance, that is with L2, and R2 is capital R2 is our variable resistance, and R3 and R4 are the known non-inductive resistance. So as we know the condition of the balance, what is the condition of balance? We have seen in the last lecture, in the balance Z1 Z4 is equal to Z2 Z3. So Z1 impedance is the impedance, total impedance of this branch multiplied by total impedance of this branch, that is Z4, that is Z1, and that will be equal to total impedance of this branch, that is Z2, and the total impedance of this branch, that is Z3. So by putting all those values, we have seen the combination of resistance and inductance in the series. So what will be the equivalent impedance of this branch? That will be equal to R1 plus j omega L1 multiplied by Z4. Impedance of this branch is R4, that will be equal to Z2. The impedance of this branch is R2 plus j omega L2. R2 plus j omega L2 multiplied by impedance of this branch, that is Z3, that is equal to R3. Okay, so by solving this equation and by equating the real and imaginary part, we will get the value of unknown resistance and the unknown inductance in terms of the values which are known to us, as we can see from this bridge circuitry. So in this way we can find out the value of unknown inductance and the unknown resistance. Thank you.